Hi there, my name's Vince from mrtelephone.co.uk, and in this video today we're going to take apart the Master Socket 5C, see what it looks like inside, and also the Mk4 VDSL Faceplate. Now, just to quickly show you the older NTE5As, just so you get an idea of what these ones are. So this is the very old one now, and if you have a look, if we take that one apart, you can see on the inside we've got the surge protector here, we've got the outer service resistor and the ringing capacitor, and this one here does not have any bell wire filter. So if you were to look at the front plate, there's no bell wire filter on the very old ones. So then after that one, we got basically this version that we've had for the last few years, and on this one has got a bell wire filter. So if you were to have a look here, again, it's all printed circuit boards with solder joints, and that's the bell wire filter here. And if you have a look at the back plate on this one, what they did is they got rid of the surge protector, so we've only got the ringing capacitor and the outer service resistor. So for the ones that's been around for the past few years, they got rid of the surge protector. Okay, so that's the old ones, but as again, if you can have a look at it again, you can see it's all soldered. Now on the new 5C, it was all plastic welded, so I just had to drill the points out, so obviously you can't use this socket again now. But if you have a look at it, it's a completely different setup. So inside here, there's no circuit board with welds on. It's just basically like sheets of, I don't know what the material is, but let's just call it sheets of metal. And then the components are just actually like placed into them. So if you have a look in here, that's just one continuous bit of metal, and then the you can actually remove the capacitor and stuff by just flip them up, so they're not welded into place. It's more like a sort of push fit. So you put them into there, and there's little grooves there that the components just slide into. So I'm not sure if this is a bit better design. I mean, I suppose resistance-wise, these are very big, so maybe that's why they've done them like that. Because then, if these were really small, like on the solder tracks, possibly you're going to have loss there when it comes to the broadband. So these are huge pieces here. So I don't know if they've done them like that for that reason. But here we've got the outer service resistor. We've got the capacitor, and originally I thought that might be some kind of weird surge protector or something, but it's not. That is actually the bell wire filter, because on the little front plate down here of the NTE5C, so that plugs in to that bit there, if you have a look there, there's nothing in, there's no components in this. It's literally just the metal pins at the top go through all the way to the pins down here, and also the metal pins here, so everything's connected to each other. So there's no components there at all. And if you have a look back at this one again, so we've got wires. This one here is the A track, so this one here is the A track, and that goes straight down to terminal 5 or pin 5, and then you've got the outer service resistor that goes up to this plate here, and then you've got the B track, this one here, that goes down to the pin number 2, and it also has the ringing capacitor that jumps over to this plate up here, which is the pin 3. So this is for the ringing up here. So you've got the capacitor jumped between here and so pins, so the where am I now? The B. Yeah, so the B goes down to pin 2, and then you've got the capacitor going over to terminal 3 here, and you've also got the resistor and the bell wire filter going across to this plate up here, which will be terminal 3. Oh, I see how they've done it now, I get it now. Right, okay, so basically you've got terminal A here, which goes down to pin 2, then you've got terminal B, which goes down to pin 5, and then from pin 5 here, you've got a capacitor that goes up to this plate here, along with the outer service resistor, and then you've got the bell wire filter that goes from this plate back down to pin 3 here. So that's what's going to filter the broadband noise there. And if you have a look at the tracks at the bottom, so remember on this socket here, these bottom pins here are the blue terminals down here. So these pins on this side up here are the red terminals, which are the network wiring. So that's the wiring that the service provider connects onto. And then these pins down here are the customer's own extension wires that connect onto this blue plate. And if you have a look, they're completely independent. They just go down here, they don't touch anything. So right now this track just goes from here to here and it doesn't touch anything else. It's only when you plug in this connector here that it bridges the top pins to the bottom pins. So when you plug that in, all the 50 volts up here now travels down to these pins here, so it makes these ones live. So that's why when you unplug the faceplate and you plug your phone into here, you're purely testing the components up here and you're not testing anything down here. So that's how you isolate, that's the demarcation point between their property and your property down here. Okay, so that's how that works. So I'm not sure if that's a good thing or a bad thing that it's not soldered. I don't know if there's any reason for it. Maybe it's cheaper to produce that way, or I don't know, maybe, I mean, to me it looks like it's possible that it could come loose. But obviously they've done their testing on it. Now, okay, that's the actual 5C. Now, the Mk4 VDSL faceplate. Let's have a look inside here. Now this is all soldered and looks very similar to the insides of the previous Mark III version. So again, we've got this set up here. Now remember, when you plug this into here, again, this is like a demarcation point now, isn't it, between their property and your property down here. So up here is the network wiring and down here is the extension wiring. And if you have a look, so you've got the 3 pins up the top, but remember it's only going to be working on pins 2 and 5, so the outer pins. So the outer 2 pins, if we have a look at the back, so that's these pins here, this pin here and this pin here, and they also connect up to these ones here. So basically these 6 terminals here are for the top set of pins and these 6 terminals are for the bottom sets of pins. So this is the network wire inside up here, and this bit is the customer's wire inside, the extension side. Yeah. So if we have a look there, on the incoming wire, you can see the track goes up to this one up top here, and then if you have a look at this other incoming wire, the track goes to here. So that corresponds to this here, and then it comes out on this side. Now I presume that that is the rain filter. That's R-E-I-N. Google about it so you can read up about it. And then from there it travels down and it goes to one of the middle pins of the RJ45 stroke RJ11, and then on this track here it travels down and it goes to that pin. So basically the raw signal, the unfiltered signal, comes along and it goes via the rain filter and it goes across to the middle 2 pins of the RJ11 stroke RJ45, and then it travels down. So if we follow this track down, it goes around here, around, and then it goes up to this point here, which is basically one of the hardwired ADSL. So you know this little red terminal here with your A and B wiring, if you want to hardwire a wire onto it to move your router to a different room. And then on the other track, this one here, it goes down, like I said before, to the middle pins of the RJ11, one of the middle pins, then carries on going down, goes around here, branches off there, I'll show you that in a minute, goes down here, goes along, and then it goes to that track there. So basically the raw signal goes via the rain filter into the RJ11 and then round to these 2 bits here, and then, which is the hardwired, so again that's the raw signal. So if you want to take that to a different room, it's still going to be the unfiltered signal, and then after that it then starts bridging out. So if you have a look at, where are we now, so this track here, if we go back up to here, you can see it bridges out this way, and this track goes out this way and goes off this way, and then basically that track there after these 2 then goes all via the filtering, and what it will do is it will then filter this socket here, because this is where you plug your telephone in, so this will be the filtered signal, and then from there it will then also go onto the bottom pins here. So basically the bottom pins here are now filtered, and when you plug that into your, do you remember this part here? Let's roughly put this back together a second. when you plug this part back into, which way round does it go? Hold on. Phone that way. Right, so when you plug that part back into there, because the bottom pins are now filtered, it livens up the bottom pins down here which are filtered, which goes to your blue socket here, which then goes all off to your phone extensions. So that's why when you fit one of these Mark IV faceplates, you don't have to put filters in any other extension sockets. You can get away with, throw away all your micro filters because they're not needed anymore, because of the bottom pins here, they filter everything from this point onwards. So I hope that makes sense. So basically this bit up here is the unfiltered signal, and the pins down here are your filtered signal. So yeah, I hope it saves you having to take it apart anyway. So I hope you like the video. If you do like it, if you want telecom stuff, not these sockets because I can't sell these, but other telecom stuff, please check out my shop when you have time. That's mrtelephone.co.uk. Thank you, take care, bye now.